Hello, folks. Welcome back to my combo corner, which is what I've nicknamed this little zone where I've moved my bedroom indoors for at least the next 3 or 4 months. We'll see what happens beyond that. Good to plan a bit of your future, but not too far at once. And I have been busy with this moving process. We have now gotten a few more cool things set up, like, for example, we got our clocks and made sure that the heavy clock wasn't on the top shelf. That looked precarious for one that had glass. So we'll keep the top shelf maybe for a special item of the day. Today is a special item of the day I put up was a graphing calculator because we're going to be doing some graphing in the background while I explain some stories about the combo classroom and its current status. For those who miss the outdoor chaos, don't worry. There is a new combo class description, sorry, I'm mixing up words, new combo class episode that is not yet linked in this description. I had to start the stream to not be too late. But right when I'm done streaming, I will link it in the description. You can also just go to the Combo Class channel and see the newest ones. The new one I put out very recently, make sure you've checked out, and that is about different sizes of infinities and why mathematically you may have different sizes of infinities or such. Now, what we have here is a 3D graph that I thought looked cool out of the just few I played around with when I was trying to make the thumbnail for this stream. And what I decided to do was look at some graphs on Desmos, which is basically a free graphing software calculator thingy online that I enjoy playing around with every few streams. And I saw that on the front page they had a few things they were calling new. And looking them up, I think new may mean just like within the last year or so, that they've developed a few new tools. For example, this one called geometry, where I could construct a circle and then decide to make a line between these two, I guess. And then what about an angle? So they have, oh no, it's not updating the background. I hate when they do this. I need to close this. It's gonna look like a crazy glitch for a second, but I need to kill the background and then redo the background because sometimes it doesn't update for some reason and doesn't, once I've started the stream, it stops showing what I'm seeing through the stream on the background. It's annoying. And then it always works once I redo it. So, some tech wizard, tell me if you know what's up with that. Now, let's redo it. Here's our background right there. And here on our, oh no, I have to like resize it and stuff to make it fit again. That's really annoying. So anyway, this is a cool tool that we may play around with. This geometry tool, I guess they call it. But we also may check out mostly the one that was their 3D graphing calculator. Now, I noticed it can't do everything yet. For example, when I tried to use something involving like a, if I was like x plus y plus z equals a, oh no, it worked here. That's weird. It didn't let me do a slider here for some reason. Here it's letting me add a slider, but that's weird because look, if I say a there, it didn't like it. It didn't want to do it. That's weird. So what if I make a here? We'll just say a equals x, and then is it going to ask me? Okay, I need all three. Where's my slider option? Why isn't it giving me the slider option anymore? Oh, also I should put myself back. But does anyone know why it's not letting me do the slider option for some reason? Okay, moving myself back is like this. There. Good. Now, that's weird. Let me do the slider thing once. It offered. I should have accepted the offer. I didn't accept the offer to click the slider the first time, and now I'm like screwed. I can't get the slider option back. What the heck? Okay, anyway, we don't need the slider because we can just adjust the variables ourselves for now. Anyway, what I whipped up here was thinking, well, we have a lot of equations that looked really cool on 2D Desmos. And in fact, let me pull open 2D Desmos for a second as well. Here is the 2D one. And for examples of what we could do is find something that looks cool in 2D, which we've already played around with and we already have a lot of idea, or at least I remember, or any people who have seen those streams remember, or half remember, or maybe you don't remember, I don't know. But we're going to play around with the ones that we know look cool in 2D and then add Z in some form to them on the 3D one and see if it's able to do it. It has a hard time doing certain things. Like, for example, if I, right here, try and like zoom in and really see this, it's kind of getting it, but it's not really getting all the detail. But these graphs are pretty crazy anyway. So it's going to be glitching to, and here it's like loading. It's, well, now it looks all the way like that until if I zoom out far enough. Well, oh, that's because 1 looks more like a square, I guess. And no, wait, I thought 1 was, I wonder if that was a glitch here or a glitch when I made it in the thumbnail. Because I feel like we're using the same equation. Okay, I'm going to crash the whole system here. So some of this will be what the graph looks like. Some of it will be glitches, but I still think it looks pretty awesome. They're still developing their software and stuff, of course. And it's pretty hard to deal with this type of equation and know where every single point's supposed to land in 3D. So let's start a little simpler. X plus y plus z equals 1. This gives us a plane. And we can see that it cuts off at this point, but it is a plane. That is an interesting thing to see, that when we make a plane inside a cube at the right angle, the way it cuts off forms a hexagon. But within this cube that they're showing us, you know, that's, I guess, the amount they're able to calibrate currently or something. Oh no, is it because I'm in cube? Can I go non-cube? Is this like a non-cube version? Oh no, that just shows the graph lines or not. I don't know the difference between these two things. Okay. This is like my first time playing around with this, basically. I mean, by basically, I mean apart from doing like 1 or 2 equations here to make a thumbnail for the stream, it is my first time. Now, so anyone who's tried this before, give me any tips. Now, to take a look at your comments, hello to everyone. I can see the live chat. I don't respond to it instantaneously, but I make sure that within each half hour, I want to say every 10 minutes, but sometimes I get carried away. So within each half hour, I check the chat and respond to as many of them as I can, which isn't all of them. But if you really care about one, you can... Oh, there's one of the dogs being excited. I live with a number of animals in this new studio bedroom here. The dog may want to come in my room, but it's not allowed to at the moment. I think it'll disrupt the stream. Now, if the cat wants to come in, the cat can come in. There's actually a lot of animals here. There are 7 animals. So, now, thank you to everyone else leaving your comments. Somebody said maybe trying the equal sign to the right helps with the A. I don't know. We could see if that helps at all. A. Yes, that does help. I don't know why that helps, but thank you for the tip. So that's cool. Well, I don't know if it'll still let me on the other equation, but we'll see. And sometime when the cat's in here, I'll tell you more details about all the animals here. Somebody says squirrels. Don't worry, I am still collecting squirrel footage because I still go to my parents' house a lot. This is close to that. And the combo classroom is in a corner of their backyard. And so I still go to visit the squirrels a lot. And I still have been collecting secret footage for one of the remaining episodes of Grade Negative 2 on the main combo class channel, which will be about different animals that have visited the combo classroom, which are squirrels and a number of others. Somebody asked if we can teach the dog math. I don't know. I don't know if I'm going to spend the time training these ones, but I will train the squirrels math. Now, here, if we say x plus y plus z equals a with a slider, we can sort of try and edit stop spinning. We can sort of try and edit a, and it's not changing this for some reason. That's because it's already filling up the whole plane, and so changing it is just shrinking something bigger than this, and it still has the hexagon as all that's showing. If we make it small enough, shouldn't it theoretically... Oh, that's because we're so far out. How do I change the scale of this? I don't want to be in this box. I want to get out of this box. Grid plus this. How do I get out of the box? I want X, Y, and Z to be like infinitely far away. I don't want to see the letter. I want to see the letter if they put it somewhere else, but I want this to be infinitely far away and not be in the box. I don't know. I can't get that. In any case, unless I zoom in really close, which we could do to see, this is just going to look like the hexagon. Somebody said the tool icon. The tool icon may help us. This, it looks like it's going from a cube to a cone or a square pyramid. So, okay, that expanded it a little, I think. I don't know. This, no, this, no, this. Probably not Braille mode. And translucent. Reverse contact. Oh, graph bounds. This could be it. Maybe not. Is it? If this is like... No, it's still in a box. Just change the size of the box. Yeah, I don't know how to do it. So... graph bounds, it looked like that would be the case, but that is just saying how big the square is. Maybe that's all they have programmed for now in here, or maybe I'm just missing something really obvious. Now, in any case, we can still do cool things here. We can still look at things that would look cool in 2D and see if they look cool or if the computer can handle them in 3D. For example, let's start with the circle equation that should form a sphere if we do it at the right size here. I mean, it'll form a sphere in any case, but we'll be able to see the sphere if we're at the right angle and the right size. So let's say the sphere equation, which would be our radius squared, which we're just going to call r, and it'll... Here, I think it's fine that the equal sign's on here. I don't think it cares in the 2D version. Oh, it does care. That's weird. Now it lets me do the slider. It cares for that the equal sign's on the right. That's weird. Now, here the radius is 1. Technically, it would be easier if you're like trying to think of a circle to consider this radius squared, but it's not going to help our graph at all, and it might make the computer have a harder time computing it. We just have to know that the radius is the square root of whatever this is set to. And whoa, why am I getting 2 circles? What? What? No, this doesn't make sense. I only have 1 equation there. Why are there 2 circles? That's weird. So, like... Okay, when it's set to 4, this should be a circle at the radius with radius 2. Why are we also seeing a circle with radius 4? That is a weird glitch. That's like this right here, just saying R is 4, copied all of this, but replaced the R with not 4. It replaced the R with 4 squared. That's really weird. What's the blue one? The blue one's supposed to just be talking about what the red one means. That doesn't make sense. Okay, let's do one of our wacky ones. Let's put signs around it and see if for some reason it's gonna still give me 2 graphs out of 1 graph. This, I don't even know if this is like the right thing. Oh, this is what's wrong. The way to make our crazy graph can't have those together. I mean, I don't know this is the only thing that's wrong. Something else seemed to be wrong for sure. But what was wrong with me finding at least one of them to be what I wanted is I want to have these separate. See, this is really weird. This is sine of x squared equals y. Why is the R one telling me a whole equation about a circle? I'm just supposed to be saying a variable. Okay, I guess I can't call it R. We have to call it A. Okay. Sometimes it happens with E too. E always trips me up. If I have 5 variables here, I'm like, okay, A, B, C, and D work, and then E, it assumes is not a variable. It's the constant, 2.7, etc. The classic irrational number, because that shows up enough in graphs. So you have to, if you're labeling them from the beginning and you want variables, you have to go A, B, C, D, F. So now, I mean, there's probably workarounds to all of these things I'm explaining, but I approach this from the simplest way possible because we're seeing how crazy of graphs we can make without any computer knowledge and just fiddling around with some equations. So let's look at, okay, I might have to calm her down in a minute, that dog, if she's worried. Okay, let me calm down the dog real quick, but I'll make our circle equation first. I don't know what she's so excited about. She might not be used to me talking for this long in a row or something in the live stream fashion. So this is one of our crazy graphs that gets even cooler when we make that a variable that I won't do R for. And we can change it in crazy ways. And an inequality is even crazier. So while I put this on a slider to remind people how crazy this is, except wait, the slider does not need to have that much of a range. And it also does not need to go that fast. And it needs to show more in between. And where's speed? Do they let me choose the speed? How do I pick the speed? I don't know. There. Slow speed. So, this is going to be in the background for 1 second while I calm down that dog and make sure she see what she's tripping over. The dogs are just bored or something. Their mom is at work, their owner, and so they're bored hanging out with the cats. So somebody's saying R squared, not just R, and so the reason I'm putting R instead of R squared is because at any given point here, R is just a constant. It's a variable when I'm changing it, but at any given point, it's a fixed number. And when it's that fixed number, okay, I'm having a hard time explaining this, but imagine a circle. If I had a circle with r squared, as I'm going 1, it's 1 big. As I'm going 2, it's 2 big. As I'm going 4, with r squared, it's 2 4 for r gets me 2 big. 9 for r gets me 3 big. And oh no, with r squared, sorry, I'm mixing these up. Let's look at the circle. We're going to show it both ways. This will be a lot easier to explain if I can see one instead of trying to show you with my hands. Let's see. So we're going to copy this and make one squared. Then now we're going to look at these circles. Whoa. We don't need the signs, but that looks really cool. I don't know how that happened, that I deleted the squareds instead of those ones. But this is what we want. So here's a circle where if I'm at, and let's just do equal to make it a normal circle. And we need to reset the range on these for this to make sense. We're going from 1 to 100 with just steps of 1. So here, as I'm at 1, they're both the same because 1 squared's 1. If I'm at 4, we get both of these. Sort of like the glitch that happened earlier in this stream when we hadn't had that many equations written. And the reason it doesn't matter if I call it the radius or the radius squared when I'm looking at these graphs is that as long as I know that this represents either the radius or represents the radius squared, I'm okay. So if I have it set to 4, I could be expecting a circle with radius 4 or a circle of radius 2, which are these two circles. It's going to give the computer a harder time handling my crazy graphs if I make it calculate as just an extra miniature step in all the calculations it has to do. Look at a tiny bit harder for it to be calculating the square of any given input here. So as long as we can interpret it as, okay, wherever we're at represents the radius squared for this. So right now, that means the radius would be 2. Then we can just talk about the green circle, which will give the computer an easier time. So essentially, somebody's saying where they were referring to the problem where 2 circles showed up, where we put the x squared plus y squared and the r squared on the same side. But yeah, the equation should have been something like that. In any case, thank you all for all the comments. And somebody asked if I've tried multiplying and dividing equations, if at all. We have in 2D, but we definitely haven't in 3D yet. So, for example, if I take this, and instead of x squared, I go for x over y. And here, let's go for y over x. Well, what's going to happen here? That doesn't... Ooh, you have to have a really small range. So maybe even a negative range. So we got to change our range right there. We got to go like negative 30 to 30. And we got to make our steps smaller to see the in-betweens. So Now, this is what that one looks like, which is kind of cool, but everything's these straight lines. What if we multiply these together? Everything's getting blotted out except for a small time when they're straight lines and little infinite corridors. Now, there are some pretty wacky ones, though. Let's say that I want to know when sine of x over y plus sine of y over x is greater than tangent of x. Well, that's starting to get weird. Let's throw some a's in the mix. And now as I change this, I get strange mutating variations. And let's say I just done sine of x. That one's pretty cool. Let's zoom out a bit and see this one. Whoa. So, this is the example of things we have tried in 2D, but I want to try some similar things in 3D. And in fact, let's see if it lets me just copy this equation in there. And hopefully let me treat the a the same. Extend to 3D. Okay. So now it looks like a crazy block like that. That's because I have not incorporated z. Extend to 3D, just kind of shut it upward or something. We got to do sine of z or something because we need that third variable. And this is what they're calculating is in that cube, and it looks different whenever we zoom into it. Whoa. But then it's sort of like, first it looks like the bigger scale shapes, but then it fills them in a bunch because there's all these in-between ones it's having a hard time showing. And you get these crazy images for a second when it's glitching. Look at that. That is so crazy. That glitch looks so cool. Okay. Anyway, what if we simplify things a little bit because we want to see a little more clearly? How about this one? Okay, let's take out a little more division. And this one is very cube-like. They're all pretty... Whoa! Whoa! These are some wild glitches. Is that not a glitch? Because it's staying. Nice. Because I consider them glitches often. I mean, this is half a glitch because it doesn't get all the data perfectly. It's still, having trouble getting everything perfect. But it's not changing and refilling in. Look at that weird hole. I wonder what's over there. Can I zoom out? Yeah, what's over there? Whoa, it changed. Yeah. Maybe it was a glitch or maybe it was like a little cave. So, now what if we put all these on one side and then we put a variable over here? Right now we're too blotted out, but that could be the scale. If we zoom really far in or out, maybe that would change. We're pretty far out, I think. Okay, I'm going to zoom in a bunch of times. Is it going to do anything? Nope. Let's remove these a. Well, let's not be at -5 maybe to start. For what a means. There we go. When a is positive, we're getting some better results. Are these really what it looks like? That's wacky. See, this is just a slice of it, though. I want to change. Yeah, there. See. Is that what it looks like? Cones. Okay, I can't tell you why cones are important, but me and my crew have had some past projects and crew nicknames and such that have some relationship to the shape of a cone geometrically, and I will explain more about that someday. Sorry, I just like getting the glitches when I zoom in and out a lot. It's really hard to tell what scale I'm at. Okay, I'm really far. That's 35,000. I should get really way more far in. Uh-oh, now I'm at 34,000. It's gonna take a long time to zoom in. How do I get the scale down to some like normal size without zooming a really long time? Because I'm still in the 34,000s. Oh no, I'm zooming out. Oh no, I was going the wrong way all along. That's like when you have to drive somewhere really far on the highway, and at first you go the wrong way, and then you have to drive further. Okay, now we're getting closer. And it's getting harder to read the numbers. Where's the right orientation of these numbers? It's hard to twist around. What? Okay. No, I keep zooming out instead of in. I'm really bad at the controls on these things, and I get sidetracked by the really cool looking images. Thank you for all the comments, by the way, with people leaving extra facts and information about Desmos. I can't figure out which way is going in and out because I'm in like the 30,000s again. Okay, does zoom just work like this? Okay, in. That's as far in as you can go. 34,000. Okay. Maybe that's because of the parameters I set. Graph bounds. Yeah, that is maybe why. The number 34,000's in here. Look, 34,844. That actually might be why. Okay, we're going to set all of them to just like negative 100 to 100. Why was it X only showing a positive portion, same with Z, and Y showing only a negative portion? Okay. Okay, I think we are at a better phase. Drink some water. Gotta hydrate. And this angle looks kind of cool, and it looks like one of the 2D patterns we've made before. Okay, now I think we are at a better zone where if we zoom a bit in or zoom a bit out, we are still close to where we can see cool things in the graphs. However, it keeps filling it in a lot. Let's go really close. Now we're at like 1. Stop rotating. Okay. There we go. So now we're at a close enough level that we can see it without it glitching. I think this might actually be what that equation looks like when those are 1s. If we go a little further, we see more of them, and that's why it formed this really hard to see box when it tried to show so many so far away. So now we can start messing with things. So now we can put some division in there, for example. Uh-oh, they turned to log. Oh, they turned to spikes. They turned to spiky cones. And in the middle, you get this extra bumpy highway. An infinite road of bumps. And there's our spikes. And what if we do a similar thing over there to get a little symmetry in the mix? Well, that looks pretty wild. Now, what if we do something similar here and we go AZ over... Okay, so we'll let X go over Y, Y go over Z, and Z go over X. Okay. Now we're going to start changing our A's. Check these out at different A's. That one has some interesting stuff and kind of vanishes at one point. Let's get near the vanishing point when we're kind of far away. Whoa. Whoa, is that what it looks like right there? Look at how there's like 8 quadrants of a cube as if it's a 2 by 2 by 2 Rubik's Cube. And 2 of them are like almost cubes. The other 4 are the other 6 are mostly empty, but have some weird little spiky mountains. That's pretty crazy. The mountains grow, the mountains shrink. Okay. There it's at exactly 1/2. So, let's see what happens when we just change a few of these to other operations like tangent. Tangent is changing a surprisingly small amount compared to how much it blotted out on a 2D graph. It's almost like on a 2D graph, tangent just like did too much, but we can see better on the 3D graph, so we can see the tangent ones. And spinning is kind of cool, but sometimes I don't want you to spin thing. Okay. No, I don't want you to spin. Okay. Now, let's delete these A's and see what it looks like in simplified forms. Because I want to see sort of the simplest equations that we can make that just look insane. So we're just going to make A1 for a minute. So this is saying when these things are greater or less than 1. It looks like this. Wait, is that it? Okay, yeah, it has to fill in. There. It looks kind of like that. And it might not be perfect. It could be getting this wrong. Maybe their graphing software sucks. So treat this less like a math lesson and more like a lesson in investigating random things to find beauty. So now, whoa, I like when it goes hollow like that, and I always wish it's actually like that. And then when it gets filled into its a more accurate form, I'm like, dang it. So people let me know if they have any suggestions for other graphs as well. And for now, I know what to try, which is, so when we make some of them squared, things get crazy. So we're going to make some of them have exponents. And we might even remove some of the divisions to, let the exponents still have room to breathe in the computer algorithm. But for now, the main thing is we're going to change these tans back to sines just in case. Now, let's see what happens if I square one. Whoa, that's cool. That's one of the formations of our 2 of the 8 are mostly filled in. Now, what happens if I square a thing or two? Whoa. Now, that's crazy. Now, I'd like you to imagine these as landscapes and think about which landscape you'd like to live in the most. And if it were a landscape, what are these? Are these stalactites or stalagmites or tree branches? Are these little trees growing on a scape? What size is this? And would you like to live there? So, what happens when we square another one? Okay, we're getting a bit spikier. And we can kind of guess the direction we're going if we squared the other one. So instead of just getting it more blotted out, we're going to remove some of the bottom ones. And we're going to do something a little crazy. We're going to go x to the power of y to the power of x. No, we're going to go circular. So y to the power of z. And then z to the power of x. Can you handle this, computer? I don't know if it can handle it. Yeah, come on. You're trying. You're trying. I know that's not just what it looks like, but you're trying. Okay. The computer cannot handle that much. We may have to just do a smaller thing like this. Sine of x plus y. Oh, not and all that. I don't want to destroy the computer. Okay. To the power of z. Whoa, it's all up there? Is it really all up there? That's pretty neat. it looks like there's like planes where it's full, and then in between that there's a bunch of stuff. But here at this angle, it looks kind of like a house. If you put in some doorways, would you live in that house? You know, this would be your door, one of these spots, because could go down the hallway, and then you could have a door over here as like a bedroom, and then this way would be your kitchen and stuff. So oh yeah, if it's for a single person, that would really work, because that could be the bathroom back there, and that could be the bedroom, and that could be a kitchen and like miniature dining room. That would work so well. So what a house we've built. um Now what about if we go a little different? Is it changing it much? Very slow. Oh, built another wall. No, we don't want this house. We don't want A equals 3.5 for our house, because like two really thin hallways. Come on. Okay, so get rid of that hallway. What happens if we went further? Does it start disappearing more stuff? It probably does. It was like starting to add stuff that way. It's okay. We'll build other houses in the future. For now, we're going to try something kind of crazy. Will it let me make the exponent be sine of z? Okay. Is there a scale where there's more visible? Yep. It looks like this, I guess. That's wacky. This is a strange, scary place to be lost. It's not a house. Okay. But that is a equals -5. What happens if we change it? Maybe at a different scale, it becomes a house. So, going up a little further. Now it still looks like those lines. Oh, what's going on there? Okay, that is weird. Now they're separated and there's air between them. This is like a weird obstacle course for people who can fly, or ghosts. Now, okay, what about in between? I feel like that could be a functional house if you had those walls but a little bit of gap between them. Nah, I don't want to live there. I like the other house better. So anyway, what happens if we do some other messing around? Like, what if that's multiplication instead of addition? Well, now we've gone to a rainforest. Whoa, that's pretty wild. Okay, now it's filling it in. Look at those little ripples on top, though. Those look neat. All right. Now, this one's really blotted out, so we're going to have to try something else. And what we're going to try is separating these. We're going to do sine of x to the sine of z, and then maybe we'll do sine of x times sine of y all to the power of sine of z. We'll put sine on each of them, but we'll try adding or multiplying them together. Not another one. That. And now it looks like everything's over there. Why is everything over there? Okay, never mind. Okay, whoa, these are like... Okay, you know how in a 2D version one time we made a burger factory by accident? I swear it looked like little hamburgers from top to bottom with their fillings, and there was like lines and assembly lines of them being made. That's what the graph looked like once. So it looked like a burger factory, I swear. And it's on a previous live stream. I have proof. And this time I'm saying we got a milkman's truck, because if I was a milkman and I wanted to give him a little room, maybe put a little cardboard between there. It was a kind of bad packing job, but it's a milk factory or truck of some sort. Now, what if we go a little further? That's a lot of milk cartons. Now they're all stacked in a giant box. Doesn't that look like a giant box containing drinks? Like with little caps? Okay. Now it's glitching, but it looks really cool. And that's too far to see what's going on. This is the milk crate factory at this angle. Now, what happens if... Will it let me? Well, let me do another one. Another layer. If I zoom in a lot, can we see anything? Okay, what happened to our milk cartons when I did that? Um, okay. The funny thing is if I went from the right angle and I was like at the axis 0 being here, at the right angle I could go flat and it might look kind of like a 2D graph for some graphs. Other ones would have stuff in the background showing. Now, that looks kind of almost checkerboardish for a minute. Now it looks like a pond of fish. Whoa, okay. Whoa, it really looks checkerboardish now. Oh my god. I said it looked. Oh my god. I said it was going to look That was really weird. I said it looked checkerboardish when it barely did. And then I zoomed in and now it looks really checkerboardish. That's really weird. That's crazy. Okay, I guess a checkerboard's our other lucky item of the day, but I don't think I have one here. Maybe I have a checker. I don't know. I have a bunch of old other little items that I packed up. Oh, this. Do I have a checker? There's like actually a chance I do. I have some random old game pieces. I used to collect a lot of weird little things. I got, miniature strange items. These things. Oh, okay. A lot of the items, some of them are personal, but I can show them as long as I don't show the whole box. But I would collect like little jars of stuff and, dice and collect strange game pieces and collect. There's some weird dice here too. This one says mid, end, reverse. Are there 3 ends or 2 mids? And then, any 2. And then one that is like, looks like someone censored it. It got all smudged or destroyed somehow. It looks like it says wild, but it could say something like mild. Who knows? Now, out of all these things, I don't think I have a checker, but that's okay. There's a lot of cool things in here. One thing that my friend gave me once, we play these marble games once in a while. Not the old school type with a circle, but a different style of marble game I'll explain someday. And he gave me a thing of marbles with all of the Looney Tunes characters individually on the different marbles. And that's pretty crazy because Looney Tunes is also a pretty historically classic cartoon. And you can't really see them, but each one has a Looney Tunes character on it. They're on, some of them it's on the other side, Anyway, a lot of cool items here I don't think I should put a bunch of marbles on the bookshelf, though, where I'm stacking items. So, anyway, someone's saying we are making square waves, and someone says a real-life mad scientist. Well, I don't mind that term, a mad scientist. We're going for chaotic good for our vibes here. It's our goal. And lots of fun, different things. Somebody said I'm working on a game, and that's cool. What is it? Now, I've been working on many games, and I will get to the game portion of the stream in not too long. And for the game portion of the stream, what we're going to do essentially is explain something related to a few earlier streams. I talked about a card-based game that I was working on. In fact, I've talked about 2 different layers of card games I've worked on. One that's quite complex and will take a long time to develop, and another that I think is really cool for its simplicity while working really strategically. And that one I found a crazy discovery about my goal target number. I thought 31 worked really well as a target number. Well, I found a way to make 31 work shockingly well as a target number. So our lucky number of the day is 31. Now, I already have written on here 1 + 1 = 3 question mark because it was empty and I wanted to write a dumb gag. So since we already got our 3 and our 1 on here, all we got to do is cross off everything except one of the 3's and the 1, and then put a little arrow putting the 3 before the 1, and there's our 31. not these ones. And that one goes there. All right, so I don't even know if you folks can quite see that, but in any case, that's our lucky number of the day. So getting back to the graphs briefly, and then after we do, sometimes we do a miniature intermission when I have to run to a bathroom and just take a breather because talking a lot in a row, sometimes I just need to collect my brain for a second or two. And once we do an intermission after that, I will talk about my card game and I will talk about some other interesting life updates that are occurring in addition to the studio here. And if anyone thinks that any items that I have in the old combo classroom would work well here to remain safer, it's a little safer here without the rain and such and without the fire, that let me know and I can always move other items here. I still have more cool things to put in the background. We're back to milk cartons. Why is it always doing that? Okay. Now, it's the scale is trippy. Okay. Now, let's try some other stuff. Going from almost scratch. What if we say we were going for a sine of x to the y over z? What does that look like? That's a relatively simple one. Am I in the wrong zone to see it or something? I might be in the wrong place to see it. No, I can see it if I zoom to a certain scale, but it's over there. It's on that side, I guess. All right. Okay, here we're starting to get to a strange maze-like zone. Looks like you got some walls and like that's a room right there. See that room right there? But that's a room that you don't want to be in. It's very spooky. It's like door to fall, door to fall, door to you think you're safe, but you actually fall, and door to brick wall. So don't want to be in that room. Unless there's cool stuff that we can't see on the other side and you don't actually fall. There probably is. Now, what about something like this? Sine of x plus y to the sine of z. That was kind of what we were trying before, but whoa, now we got a triangular room. So what other sorts of room can we get? And to anyone coming in new, no, I cannot figure out how to make it the whole screen. We tried a bunch of stuff, but if some wizard wants to let me know how to make it not have this cube around it and be the whole screen, that'd be helpful. This is my first time trying these. Okay, let's try some other sorts of things. Is there any way they let us... Nah, they're not going to. Okay. I'm trying to think about what could work here. Like, are they going to allow us to use the gamma function? Can we use, which they might just represent with a factorial for certain value. The factorial might represent the shifted gamma function on those ranges. And that would look really cool if we can find a way to make that work. But I don't know. Can we see like y equals x factorial plus z factorial? All right. Well, I'm not sure if the factorials will help us in this little box right now until I figure out the right way to make our gamma function find its right zone. However, okay, somebody said some weird amount of things to press for full screen. I'm scared to press any combination of buttons to make it full screen. So let me know if there's something on here I can click to make it full screen. Or I'll look up that weird combination of buttons later. Now, it's okay. We're just going to be in the box right now. We're not doing a super long stream today. I just wanted to check out this software, and we're going to try a few more. Say something interesting about my card game, and say some updates about my future. In fact, we probably won't even do an intermission on this stream, because I do... Let me just begin that portion for a minute, and then we'll go back to the graphs. So we'll go back and forth a bit. I'll say that pretty soon I'm going on a trip. I'm going on a trip with my mother. And also, an old family friend of ours is going to come and help me film. And so, because I actually almost was going to do it with either my brother or my main camera guy, but an old family friend is going to help us film. And my mom also sometimes needs help walking and things like that, and she's, getting older. So she wanted to take a trip, and we are going to somewhere cool and tropical. I'll see to what degree I want to tell you the exact details. Probably will once I get there. But there will be a few days when I'm in a rural enough part. I might not even have Wi-Fi, even if I wanted to stream. But then later in the trip, I may be able to do a live stream. If not, I'll film some very cool footage for the next episode after the one that came out pretty recently about infinities on the main combo class channel. The next one will be about integer complexity, something I've been talking about for a long time that actually relates to the game thing I'm going to talk about in a moment. So we'll do a few more graphs real quick, and then I will wrap up with explaining the thing about my game that I found. So to mess around with a few more graphs, I am going to go back to the trig functions and just try some other ones. Secant of x squared plus secant. The secants went pretty crazy when we tried them on 2D. Equals secant of z squared. Are we going to be able to see this at all? Here it looks just like a bunch of dust. Well, from here, the bunch of dust looks like it has a cubic shape that's not even the outside of the main cube. And then from another angle, it looks sort of like it had a different shape. But maybe it's just trying to process it and having a hard time. What if these were multiplied? Well, that's interesting. I'm having a hard time zooming. I'm trying to zoom in and out, but it's like being really slow on it. But when you zoom in, we are seeing these spiky things. But then, yeah, it fills in again. This one has like way too much infinite density and dust. It's trying to get all of the nooks and crannies. Really, there's like parts that are there and parts that aren't there, but it's all the dots where and lines and curves and stuff where it is there. It's having a hard time showing. So let's remove the squareds for a second and just see what it looks like just with the secants. Whoa. What's going on here? Whoa. Whoa. That's pretty crazy. See, I told you the secants go hard. The secants are crazy. I forget who first recommended trying a secant in a stream once. Shout out to whoever goes through all the stream lore, because almost every stream I do gets saved as a video. So to whoever in one of the streams once recommended I try secants, and they were really cool looking right then, so I kept trying them. Shout out to that person. I probably would have discovered it anyway because there's only so many trig functions, but still. So if we zoom out a little bit, we can see these like weird, like cone-like things meeting and merging and flipping upside down, forming little cups and not quite spikes, but that's interesting. What happens when we put an A in the mix? So let's start by just putting A in these ones. Well, that's making the cone-like things stretch and morph. What if we put it in this one too? They look like clams now. Okay. Don't they look like clams? They're like half of them are open and half are shut. Anyway, what if it was only on that side, RA? Okay, so now for more of an experiment, we're also going to try putting them all together over here, first with pluses and then with multiplication, and we are going to say, I would use inequalities, but it's already filling up so much of the screen just where the lines are, so that this stuff equals A. Whoa, look, we created little orbs. That's pretty cool. They're like eggs, egg-shaped. All right, we've created burgers, we've created all sorts of foods, and now we got eggs. So that is just wild that you can just create stuff like this. Now, like, I'm shrinking and growing my little orbs. They look like they're doing weird things, but they're just going off screen. Pay attention to, like, that orb, which doesn't have much room to go off screen. Oop. Okay. Now what happens if I put a plus on one of these? Uh-oh, no more eggs. Oh, I was about to say no more eggs, but I'm wrong. We get this pattern and eggs when we're at the right setting. That's pretty cool. Now what happens if they're all added? We get this pattern with, oh, we do still get eggs. The eggs are just like rarer looking. This looks like one of those like playthings you'd go on as a kid on like when I was a kid they had them at McDonald's and stuff, and they also had some at random jungle gyms where you like climb up in and out of little like chutes and stuff. And it looks like that. It looks like you know how you'd go in a ball pit as a kid. This is like some weird surreal freaky ball pit where the balls are these instead of like a bunch of small rubber ones. Now, changing this does give us some crazy different realms. Would you live in this? This is not a house. This is some weird apartment complex of the future. Now, let's see. Or it could just be some crazy guy's mansion. So, what happens when we start messing around with these again, now that it looks so cool with the sequence? What if I square one of these? Okay, let's zoom back in a bit. Those look pretty wild. Now, let's try and make more of them squared. We'll start with just two. And when it goes really crazy is when they're to each other's power or divided by each other and stuff. So let's actually do that instead of just letting 2 be the exponent always. I want this over this. What if I have this over this whole thing? Whoa. These remind me when it gets really full of these things called Mandelbulbs. That's like the Mandelbrot set, which I'll do an episode about someday. But 3D. What if these are multiplied? Ooh. Whoa, they got kind of thin. Okay, now how about if we have just one on the bottom and two of them on the top? These are pretty wild. I love just playing around and making the coolest shapes that are like really simple equations. Now, I don't know if it's exactly what's going on because, it seems like the computer program has difficulty at times, but it's still having a lot of fun. Well, hopefully, it's having fun generating it, but I'm having a lot of fun working on it. Just finding different shapes that we can create. Now, thank you to everybody who has left random comments as well. And I think while I finish doing this, let me note the things about my game. So for the rest of this, I'm not gonna, well, try not to like ooh and ah too much on all the cool stuff that passes by. I'm just gonna be fiddling around with different combos of these. But I will tell you some things, such as, like I mentioned, I'm going on a trip with my mom soon, and that's actually going to be in 2 days. And so there's a small chance I won't be able to release anything in the 5 days that follow that. So I might try and do another live stream tomorrow just to make sure I get a little bonus content for my combo lords before I leave. But when I'm gone, I'm going to be filming some really cool stuff. And the next integer complexity episode, since that's what I can, don't worry if you don't know what that means. I think it's one of the most underrated concepts in math. And so the next episode, I think it might be the most underrated concept in math, in fact. The next episode about that might be pretty long, and it will have some shots in a cool tropical location I'm at. Now, apart from that, I made a cool discovery about my game I wanted to mention, which is that earlier I had been thinking about different possible target numbers that might make sense for my game. And my game involved having two piles that reset at the number either 0 or 1. I was juggling around in my head, and currently I've settled on 0, at least for the main version. Having a range that typically would be any number up to 99, all the two-digit numbers, if you count a 0 in front of the... Sorry, it's hard to talk and change these, but I'll try my best. A 0 in front of the one-digit numbers, and then it's just all the two-digit numbers. And those, let's also, change scales too, I gotta remember. So, with that game, you have some cards, and I believe you're going to have to draw 2 per turn, and you get to play as many as you want per turn, but you must play at least 1 per turn if you can. The player who makes the 2 piles, which will change numbers, equal the same number on their turn, gets all the cards in the pile, which are each worth 1 point. And you're trying to collect the most cards as you go through the deck. In the version for now, it's a shared deck, but there could be variations where you'd construct your own deck. Now, I was thinking of which numberations I wanted to include on the cards that edit these numbers, as well as what target numbers there were. Like if my target number, for example, was 11 and another one was target, in my head is just meaning the larger of the numbers, because I know I want the lower one to start at either 0 or 1, and I've gone with 0 for now. And you have to make them connect. If the target had been 11, then you could do like +1 on the 11, then divided by 2. And then on the 1, you could do, from 0, you could do like +2, then times 3. And then they'd both be at 6, and you'd get them because they're at the same number. And it has to result in a whole number between 0 and 99 for this version. So you cannot do something like ×2 on an 80. That'd be too big. You also can't do like divided by 2 on a 7. That would be fractional. So I wanted 31 to be the target number because it seemed to work so well to have a bunch of numberations, and having 31 take 4 steps to reach in those numberations, at least 4 cards to link it to my lower number, my 0 or 1. And then I even thought of other target numbers and kept being perfectionist in my head as I thought about which one made sense. And I developed a batch of numberations. See, here was my goal, first of all, was to make my target number have many ways to get to it in the minimum amount of ways that you could get to it. By which I mean, if I have some target number and I can get there a ton of ways in 4 steps, I don't want to be able to get there in 3 steps, or you're just hoping to draw those cards and it's more luck based. I'm going to pause on the we'll come back to these just in 1 second at the end. It's hard to talk about, remembering certain things while I'm trying to do the graphs. But with these numeration things, I was looking at different combos and trying to find a target that if you could get there in like 4 steps, for example, you couldn't get there in a fewer amount of steps, but you could get there in 4 steps a ton of different ways. So 31 was working pretty well with some combos of numberations. And guess what? I found a relatively sensible, like not using really random seeming ones like plus 17 or like 82 divided by n or something. Like, I'm not using really random ones. I'm using ones that seem logical and sensible to play with. And I've developed a set of about 25 maybe numberations. They're relatively simple because you have plus 1 through 5, minus 1 through 5, times 1 through 5. I'm not sure if I'll include 1, which would be kind of like playing a skip my turn card. I'm not sure if that'll be in the mix or not. Divided by maybe 1, yes, 2 or 5, 2 through 5. And then squaring or square rooting. Doing a digital reverse in base 10, which on that one, I'm not allowing a 0 in it. So it has to digit reverse a 2-digit number into a 2-digit number. So you can't like take 7 to 70 or 70 to 7. It has to be a 2-digit number to a 2-digit number. And then there's a few other ones that don't really change the number per se. They're just like gameplay ones, like one that clones the last card. Possibly one that undoes the last card I might include. And in this game, I haven't explained the full details here, but don't worry. I'll make a whole episode about it at some point, and once I've designed some trial cards of them, here are some index cards I'll design some trial cards on. I already made a trial deck, but it was from some old ideas of it, and it's not exactly what I want anymore. So I'll make a trial deck that I'm going to play on my trip with my mother, and we'll test it out. And now, the main thing I wanted to say about this game that was really cool that I found just last night was that I realized I found a version of this combination of numberations. I think I listed them all. Oh, no, there's actually more. There is additionally, so remember the factors of 10, and we are stuck in base 10. I'm designing a base 10 game for now because it does line up a lot closer to just people understanding things like digit switch within base 10. That's the way we write numbers for now. I'll make a base 6-ish game using dice at some point in the future as well. Now, for this base 10-ish one, the factors of 10 are 2 and 5. So I did also have plus 20, which is a fifth of right above the maximum, and plus 50, as well as the minus versions of those, minus 20 and minus 50. Those are minus 50 and plus 50 makes sense because that's sort of around the halfway point. Plus or minus 20 is the one that I wasn't sure if I wanted there. I couldn't include plus or minus 10, or you could get to my targets like 31 too easily. And I didn't want my target to be something really high up that people would have to remember the factors of all its nearby numbers. I wanted it to be low enough that you might already remember the factors of the numbers that were near it. Like with 31, you kind of know 32 is made of a bunch of twos if I were to go there and then minus one. And that like 30 you might remember is 2, 3, and 5, and so on. So I did have 72 on my mind for as a target number for a while, but it didn't make sense. And remember, you can edit the target number as well. The goal is just to make the piles match. And they can even cross each other, theoretically. Whenever somebody sweeps the piles and gets them, they do end up keeping those cards, and then I'm still deciding if they get to continue their turn or if it switches turn. And it's something along the lines of that you draw 2 cards at the end of your turn, and you play at least one if possible, but you can play as many as you want in your turn. Now, but you want to save them because you want, you don't want to play a ton if you think the opponent might be able to sweep them. Now, there's a lot of strategy that I've figured out in this game that I want to test out. Now, what I realized is that with that numberation set, 31 from the number 00 is the only number, the only whole number, obviously, the only number between 0 and 99 that takes 4 steps to reach. But there are tons of ways to reach it in 4 steps. There's a unbelievably large amount of ways to reach 0 and 31 together using 4 of those numberations I mentioned. Although every single other number from 0 to 99 can be reached in 3 steps or less. So once I got there, I was like, okay, that's a good batch for my starter set of the game. I like that. Something about that just feels fun and cool. So there will be other target number recommendations, in particular things like you may remove certain numberations from your deck if you're going for certain target numbers or to make them too easy. There may be versions like, oh, if you're playing with kids, remove these numberations and this is your new target number. Sometimes you may also, to get to 31, flip a 13. In any case, I love you all, and we're going to go back to... Now, somebody has to spell my name if they mean to me. My birth name is Dimitri with 3 I's. My nickname and mononym is Demotra with 3 O's. Now, going here, let's just play with a few more of these, and then I do have some stuff to work on, because like I said, I'm leaving on a trip on Wednesday, but there will be a lot of cool combo class filming involved in that trip, in the midst of getting to hang out with my mother. There we go. This is a strange type of apartment if we are considering these houses. Whoa, this is like intertwined chains at a certain angle, or links. And let's make these a little simpler. Then maybe we can see a little more going on. Let's just put all this over just Y. Now they're long. Now I keep forgetting we can also adjust our A for what they're equal to or not. Are they going to touch? Are they going to touch? Now, what if that's a plus instead? Now they are touching. Oh, no, wait. Those are different ones. Okay. So that is actually most of what I wanted to fiddle around with on the stream, because I don't really know what is really cool to do on here. Some other ones we've tried just include, well, it's harder when there's 3 with Z, because with 2, I can take X related to Y in some way, and then plus or times Y related to X in a similar way. But with 3, it's sort of like, oh, now if I want to go like X to Y and Y to Z and Z to X, there's a lot going on in the graph, and it doesn't look as much like separated blobs or stuff, except when we made those eggs for a minute. Now, what we'll try before we wrap up is putting some more where the Z is on the opposite side of the X and the Y, and we don't have an A. So we're going to try, for example, if I have sine of x squared plus secant of y squared equals tangent of z squared. What does that look like? That looks pretty wacky. Whoa, yeah, this looks like this whole like series of cliffs or something with stalactites and stalagmites. Cliffs and caves and such. Maybe we do need to throw an A in these. So, yeah, add a slider. Oh, I didn't need 2 sliders. Oh, it's not liking this. Okay, it's liking it again. So here we got our caves. And what happens if we turn this into division? Whoa, that one was kind of cool. Hey, look, wait. Doesn't this part look kind of like an infinity symbol right there? You see that infinity symbol right there? That's a good time to end on. Because my newest episode that I want to make sure you watch, I'll link it in the description when I'm done streaming here, is about the different sizes of infinity, involving things like Cantor's diagonalization hypothesis or argument, the continuum hypothesis, the Aleph numbers, a way to enumerate all the fractions, and so on. So now I believe is a good time to wrap up and say that I love you, Combo Lords. I'll probably do a stream tomorrow in the main Combo classroom with its modifications that you'll notice occurred within that episode I mentioned. And hope to see you all soon, hopefully tomorrow. I love you all, and I'll hopefully be back to a quicker release schedule with these shorts and bonus videos soon, which I've been saying for a while, but I truly believe that to be the case coming up soon. I'm done with a lot of things that I'd been working on, including one of the more obvious you already know, being this new place where I am sleeping in this new zone now, but it is not far from the main combo classroom, which will not get, I want to say it's not going to get destroyed, but I'll say it's only going to get destroyed, hopefully, on film. So, okay, not permanently. It will keep regrowing. Grade -3 will also have main combo class. So, got a lot of smart, cool comments, and I appreciate them all. Wish I could answer more of them, but I should work on some things now that it's about to hit 3 p.m. here. And I love all of you so much. I do have some shorts I filmed, so perhaps I'll post a short later today. I'll post a short either today or tomorrow, or maybe both, because I did film 2 of them yesterday. And I also filmed some crazy intro footage for my integer complexity episode. So, love you all so much.